On to volume, which is how much stuff can I fill inside of this three-dimensional figure. Now what we're finding is the number of cubic units. And once again, throwing it back to surface area and what we talked about before break. One of the things that you may or may not have been aware of is if I took a prism, if I took this prism and I somehow slanted it and the base was still the same and the height was still the same, do you think that we would have the same surface area? Actually, I don't think so. No. But when we're talking about volume, the volume would be the same, whether it's a right prism or an oblique prism or an oblique cylinder. Okay, and there's a fancy name for it. It's Cavaliere's principle. But the bottom line is the volume of a right solid having the same base and height as an oblique solid, they'll have the same volume, right? So you have found the volume of stuff like problem 1 before. You probably did it way back in middle school. How would you find the volume of that rectangular box right there? Length times width times height. You know that. So for this rectangular box, you would do 12 times 5 times 6, and that would give you 360 cubic millimeters. Easy peasy. You've done this before. However, we're not just going to be finding the volume of rectangular prisms. Consider length times width. In the context of this figure, if I had done just 12 times 5, what would I be finding as far as that prism is concerned? 12 times 5 would give me the what? Area of which rectangular? The base. The area of the base. So, in your notes, since the calculation length times width yields the area of the base, which, remember, on the reference sheet is abbreviated as a capital B. Remember, there's a key on the reference sheet. The formula that I can use for any prism in order to find its volume would be area of the base times height. So, once again, let me stress to you that beautiful relationship between the formulas for prisms and cylinders. They're the same basic idea. Okay, so on the front of our notes, let's put the phones away. On the front of our notes, the formula for a prism's volume was capital B for area of the base times height. What kind of base does a cylinder have? Circle. Sometimes, or is it always a circle? It's always. And what's the formula for area of a circle always? It's pi, that's the pi r squared formula. Okay, so volume of a cylinder is pi r squared h. Once again, let me try to allay your concerns. The formulas are here on the reference sheet. You have them. They're all here. You don't have to memorize them. You just have to know how to use them. So in problem 3, we're asked to find the volume of this cylinder and leave it in terms of pi. Oh, what's Caitlin's favorite phrase? That's exactly what you're doing. They have given you everything that you need in order to just plug and chug it into the formula. So volume equals pi times 6 squared times 14. I believe that gives us 504 pi. You. Cubic meters. And there's a your turn problem for it. Oh, what? Who? Where? Okay. Yes, sir. What do you think it's pointing at? Okay, continuing, gentlemen and ladies. All right. The volume. Shh. Let's refocus, please. Today's are more like this guy right here, which is a composite figure. All a composite figure is two things put together, right? And what you're looking at in this figure in problem 4 is a cylinder with a hole in the middle. Okay, so how would I find the volume of that cylinder? If it's a cylinder with a kind of cylindrical hole in the middle. Exactly, yes. There is, however, another way to look at it. There is another way besides find the volume of the large cylinder, find the volume of the small cylinder, and subtract. There is another way to look at it. Anyone seeing what that other way might be? Okay, think about how we take, I'm sorry? You might be onto something. Let me clarify for you the other way. Remember at the beginning of our lesson how I talked, I stressed to you, no, that was 5 minutes ago, Mrs. Clouse, I don't remember. Remember how I stressed to you the relationship between the formulas of prisms and cylinders. Just area of the base times the height. Well, couldn't I find the area of that little donut that is the base and then multiply that by the height? Absolutely. Either way would work. Either way would end up in the same place. So whichever way makes sense to your personal neurons, you go with that. I'll show you both ways that I'm describing. Pick what works best for you. Okay, so in a problem like this, if I'm finding the volume of the large cylinder, it would be pi times 100 times 18. And I'll pause just in case there's any confusion about the 100. Okay. Notice that the problem is telling you that the big diameter is 20. If the big diameter is 20, that means the big radius is 10. Remember that we have to take that radius and square it. Okay, so this is 1800 pi. Say that again?
They're on 1800 pi.
You're just on a roll today. Okay, volume of the small cylinder would be pi times 49 times 18, which is 800 something pi. 882 pi. So the volume of the composite figure would be 918 pi. But we good? No?
So that's how did you get that?
I subtracted
You subtracted
the 882 pi from the 1800 pi. And the next point that I was going to emphasize is notice how the question is asked. We are asked for the approximate volume. So at this point, yes, evaluate the pi. So 918 times pi. And let's round this to the nearest cubic centimeter, which is 2,884. Okay, but I wanted to show you two different ways to do this problem so you can see how maybe a different problem could be more easily addressed.
why did you do 200
I evaluated the pi. I did the 918 times the pi button in my calculator.
Yeah, but I got 200, 2,800.
Did you use the pi button or did you use 3.14? Ladies. Okay, you have a pi button, which will give you a more accurate answer. Yes, ma'am. Okay, once again, the smaller cylinder has a diameter of 14. You're good? Okay. Okay, like I said, I wanted to show you another way to do this problem. And that would involve figuring out what the area of the capital B is, the area of the base. The area of the base is just a big circle minus a small circle. So the area of the large circle would be pi times 100. The area of the small circle, I'm just showing you a different way. I'm just showing you a different way. Okay. Is pi times 49. So the area of the base, if I were to subtract these, would be 51 pi.
Oh, yeah.
Which means the volume, once again, would be capital B, 51 pi, times the height, which is 18, and you'd end up in the same place. And I will be activating a daily quiz on Socrative momentarily.